Praise God.
You can. Okay, just fine. So, can I start?
Please.
Okay, let's get ready to rumble, right? Good afternoon, everybody. My name is Sergey Shevchenko. I am from Supermicro company. I am based in Kyiv, Ukraine, and my title is FAE, but that's a kind of fancy name for pre-sales engineer within the company. So I am doing complete solution pre-sales as well as system pre-sales, so everything technical related pre-sales and technical marketing. First off, I would like to thank our long-term and strategic partner Adsys for this opportunity. And without further ado, let's move. Just a few words about myself. I'm with the company for 7 years, and before that I worked as a pre-sales engineer within the Intel for 15 years, and for 7 years within the HP. So a strong background for technical pre-sales. And without further ado, my agenda will consist from two main parts, and within the next 30 to 40 minutes, I will cover two main topics. First, I will update you on the product portfolio. Because as you know, for instance, today, Intel has launched, yes, it is paper launch, but still, Intel has launched Xeon 6th generation CPUs. And then a second topic I will cover in more in-depth, in more details. That would be products and solutions built around artificial intelligence, AI, which is the most popular products within the Supermicro currently. To begin with our product portfolio, I'd like to remind you that we follow basically pretty simple marketing positioning guidance, which is called good, better, best. Meaning that within each of our product groups, for instance, storage systems, rack systems, GPU systems, within each group, you will definitely be able to find some of the products which are positioned as a good, better, or best. With the meaning that best, you are absolutely familiar with this approach. It's like Core i3, Core i5, Core i7, BMW 357, and so on and so on. So it's not a new one. The main idea is that within each of the product groups, you will be able to find some of the products which definitely fit your particular needs or end user needs. And all of that is based on this good, better, best approach. Best meaning that the product has features which is absolutely scalable in terms of number of I/O slots, number of DIMMs, maximum supported TDP within the CPU. So the main idea is that you can scale internally platform at the maximum level according to the limitations which are imposed by form factor. Meaning that definitely 2U is more scalable than 1U and so forth. That would be best positioning. Better positioning means that we have balance between cost and features within the product. And good simply means that the product itself is highly optimized for the low cost. That's the main point here. And here I just put on the slide side names like Cloud DC, for instance. That product family is within the rack product group. This product family is basically positioned as the better solution because it has balance between all the features which are delivered by Intel or AMD, as well as product cost, final product cost. And another product which would be positioned as the best within this segment called Hyper, which provides maximum, which would deliver the platform from Intel or AMD. And mainstream products are basically about the cost-optimized solutions. So here is the main idea. And with this idea in mind, I'm switching to so-called product generations, because when you start to select the product within our product pages, you will immediately meet some product generations designations. For all of the cases, those designations are around the CPU or GPU used. And as you know, we have products which are built around Intel product portfolio, AMD product portfolio, and Ampere product portfolio. Also, I won't mention, because that would be not the general purpose CPU, the Grace CPU from NVIDIA, which is Grace Superchip or Grace Hopper APU, actually from NVIDIA. But main idea is that within each branch, we have generations. And for instance, for Intel, moving just from the bottom, I would recommend today focus on Xeon third generation of products, which corresponds to our X12 family of products of systems. Whenever you see on the generation description these X's or H's, you have to understand that's about generations, okay? And for third generation of CPUs, you need to select X12 systems. That's basically the point. As a reminder, second generation and second Xeon and scalable Xeon, the second gen and second ARM, which stands for refresh from Intel, they are sent to end of life by Intel, and we just follow. So all X11 products are currently in the stage of end of life. So then we'll move to scalable generation 4th and 5th, and that's about 13th generation of Intel products, Intel-based products. And what was introduced today, and some of you already aware, and you have already read news from Intel, from us, we have launched 14th generation of our product family for 6th generation of Intel CPUs. And here you have to remember that unfortunately the whole family of this 6th generation of Xeons is split in basically four different product segments. Within those product segments, there are 2 different sockets. And within each socket, you can populate it with 2 different CPUs. So that would be quite complex and complicated launch. And what was launched today, basically, Intel has launched Xeon 6th generation, which is built around so-called efficient cores. And you have probably have read the news saying that Intel has launched 6700 CPUs with the E designation standing for efficient cores. And a few words about efficient cores for those who basically resell or have at home desktop PCs. You know that starting from, if I'm not mistaken, from 11th or 12th generation of desktop CPUs, within the CPU there are 2 different cores: efficient cores and performance cores. Efficient cores means that it is energy efficient with a little bit lower performance than performance cores, but basically mostly used for workloads which do not require significant performance from the CPU. And here, with this launch, Intel totally disaggregated those cores and they just populated CPUs with the efficient cores or performance cores. There will be no CPUs with the mix of the cores. You have either 6700E or 6700P, for instance. And P designation stands for performance cores. And the main idea is that both of these CPU families will fit within the single socket. You can populate socket with either performance cores or efficient cores. And today, Intel has launched a single socket which could be populated with either of two CPUs of two families, but current availability is limited by the efficient cores only. Performance cores will be launched later. And within the next half of the year, Intel will launch another socket, which is called AP, stands for Advanced Performance. This socket will also be capable to be populated either with efficient cores or performance cores. And the main difference between sockets, it's about core count and number of channels. With this one, there is still 8 channels, memory channels per socket, and here there will be 12 channels per socket. And different core count. Current core count for SP6 efficient core is 100 up to 144 CPU cores. That's about Intel. With AMD, totally same approach, but different CPUs. And the current generation, which is on the market, it is H13, 13th generation of AMD systems. And this generation is built around two CPUs, Genoa and Bergamo. And both of these GPUs, they are built around so-called 4th generation of EPICs, so 4th generation. And within the few months, AMD is going to roll out a 5th generation of EPIC called Turin, and this CPU will be pin compatible with the current platform, which is good news. And the bad news, within this family, there will be CPUs with up to 500 watts TDP, and with the new memory speed, if I'm not mistaken, 6400 megatransfers per second. And for such systems which require, which will be capable to support such CPUs, we'll build the new motherboards with the new systems. Again, and the main feature would be that system will be capable to support up to 500 watt TDP CPUs. Okay? And that family of products, it's about Ampere, and currently we are with the Cerium or 13th generation Ampere ARM core CPUs. And basically what we know is that Ampere is going to launch Ampere 1 within the few months, which will have up to 256 cores. And just regarding those efficient cores, or so-called cloud-native cores, or you call it how you want. I mean, basically currently AMD has such solutions. Its code name is Bergamo, as well as Ampere has such cloud-native CPUs or CPUs with cloud-native cores. So, and Intel now has this kind of cores. And main idea with those cores, it's about energy efficiency, and this slide just shows you that we are talking with the today announcement, we are talking not about the whole data center, and the current announcement is only around so-called cloud-native applications. Those applications could be microservices, DevOps applications, or some network microservices or network function virtualization, virtualized network functions, cloud-native products, content delivery, and so on. So we're talking about some sub-segment of data center where you can sell those energy-efficient cores or 6th generation Intel Xeon CPUs with the product designation 6700E. That's one. And now switching gears to our product portfolio, I mean, nothing really changed. I mean, we just have still some of the product groups, just to name main product groups like Rex. For multi-node systems, as a reminder, we have two different product groups. One product group is built around blade approach, when you have active networking within the chassis. And second one is built around multi-node approach. We call them twins. So multi-node meaning that within the chassis you can have up to 8 independent nodes, and those nodes, they share cooling as well as power. So that's about multi-nodes. Then we have storage solutions, and storage usually we have 3 main storage servers. We don't have systems, as you know, but we have storage servers. And a lot of products currently launched with the NVMe in mind. Following this EDSFF form factor, E3S, E1S, E1L, and so on. So that's about NVMe solutions. Then we have top load solutions. Basically, the main principle is that you populate the node with the drives from above. And third one, still we have quite significant number of systems with the front or rear population backplanes. So that's about storage. Then we have GPU systems. And finally, 2 segments for IoT or embedded solutions. We have a lot of products built for this segment, and all of the products are very diversified. We can start from the entry-level CPUs like Atom E3 60 something, and up to the DP system fully populated with the Intel or AMD DP solutions. But the main concept that all of these systems, they are built around chassis which are capable to be installed not in the racks, but in the closets. Telecom closets or embedded closets, so having just front accessible parts in the system. So the main idea is that everything is built around embedded approach. Sometimes it's called IoT, but you can call it also embedded too. And finally, MP systems. We have current generation. We have 3 to 4 systems, which are either 4-way systems and 1 single system, which is 8-way. That's maximum scaled up approach to increase performance within the chassis. Just installing up to 8 CPUs within the chassis. So, meaning basically that nothing has changed. We just follow this general approach, having such product groups, and we just basically refresh the content of every chassis with new generations of CPUs, memory, storage, and so on. And then finally, we just a few years ago, we started to sell as a single node racks. You just purchase from us completely populated rack, either air-cooled or liquid-cooled, it doesn't matter, but you just buy it from us completely populated rack. And our rack performance in terms of number of built and sold racks today, that's around 5,000 racks per month. That's our capacity for for selling such pods to the market. And basically, here is the review of the product lines available within our portfolio. But now I just want to switch to GPUs. Why GPUs? Because this whole topic of generative AI or LLM, everything related to deep neural networks today is a hot topic. And before jumping into the hot topic, you have to understand what is the entrance ticket, how much is the admission ticket for that. And if anybody tries to understand that, he goes definitely to the market leader for building GPUs or accelerators, NVIDIA, and then immediately he recognizes that we are talking about some huge, not always understandable amount of nodes which do something. We could not definitely understand what it does, but basically we have to know that each node, the average price is $250,000. So, and here we're talking about 512 nodes, each node of $250,000, and it does something. But it really finally scares those who want to jump into this train. And what I wanted to explain you that basically this admission ticket cost is not so huge if you want or someone wants to jump on this train. And to understand that, I want to show you quite famous slides which just explains what are the stages of so-called model development and deployment. And I will try to explain you that really, I mean, the admission ticket is not so significant. You don't need to follow those huge clusters and try to understand, I mean, what does Google, what does Meta or anybody else, because there they use thousands of nodes. And really, when you try to understand the whole pipeline, you will be able to divide this pipeline, to segment this pipeline in three main stages. I will call that stage 1, stage 2, and stage 3. Stage 1, I will do some analogy. Stage 1, it's like elementary school. Yeah, is something wrong? Yeah? No?
Sorry, no.
Everything is fine, okay.
Everything is
So, okay. The analogy is that stage number 1 is for elementary school. The child goes to elementary school. What he does, he learns how to speak, how to write, how to math. Maximum is algebra. That's it. That will be the first stage. Second stage, when you move from high school to university, you have some focus, a kind of focus on the particular skill. For instance, for me, I have graduated technical university. Before that, it was like school. In the school, I learned how to read and teach. Read and write. And in university, I was able to learn how to build semiconductor products and how to design PCs, basically. That's basically my skills, which I move after this stage to the third stage, which is called inference, where I moved from my school to my first working place, and that working place was around HP products, and I was acting as the HP product manager. So I was basically applied my skills I got in the technical university to my job to sell systems, networking, and so on. And here you basically have the same three stages. They called first stage is called training, and that one is really very complicated. Very complex process of building so-called